Training.com, CWI prep course. Come visit us at our website at train-eng.com, pronounced training. This is our CWI prep course. This is as you go through some of these videos, these will be some snippets or samples out of our online training course. If you like what you see here in the sample section, come and visit us and take the course. Unlike a lot of other programs, we've got it set up so that you can do it a la carte. If you only need to, we've got different parts of the CWI course broken out. So if you don't need to sit through and take safe practices for welding inspectors, or you have some strengths that you know of and you want to streamline the process and only hit the sections where you don't really have a strong background or a great deal of proficiency, our program is set up so you can take some of these parts of the CWI online course a la carte. Pick and choose, put together what you want. Leave the rest, like a Chinese food buffet. Learning objectives. In this module, we're going to talk about compressed gas cylinder safety, handling of compressed gases, acetylene cylinder construction, proper storage of compressed gas cylinders, acetylene cylinder storage, manifolds, oxygen hazards, fuel gas fires, and common shielding gases. We've all seen these compressed gas cylinders around the work sites or work areas. If you've had any amount of time with welding, you've dealt with compressed gases. That's why I'm saying everybody's seen these. They're also very dangerous if misused. I'm sure a lot of you have seen the Mythbusters episode where they launch a couple of these guys through a cinder block wall. So there's a tremendous amount of power in compressed gas that can turn one of these things into a rocket if not handled properly or if misused. So that's why we're going to go into compressed gas and cylinder safety for a few moments and have a little conversation on proper handling and care of gas cylinders and the safe practices that are involved with using these. A typical oxygen cylinder is shown in figure 5-7. It is made of steel and has a capacity of 220 cubic feet at a pressure of 2000 psi and a temperature of 70 degrees F, 21C. Attached equipment provided by the oxygen supplier consists of an outlet valve, a removable metal cap for the protection of the valve, and a low melting point safety fuse plug and disc. The cylinder is fabricated from a single plate of high-grade steel so that it will have no seams and is heat treated to achieve maximum strength. Because of their high pressure, oxygen cylinders undergo extensive testing prior to their release for work and must be periodically tested thereafter. You can see there's a bronze valve on the top, a removable metal cap, a safety fuse, a plug and disc, pressed steel neck ring, oxygen capacity of the cylinder, 220 cubic feet at 2,000 pounds per square inch, pressure at 70 degrees F, water capacity approximately 2650 cubic inches. They're 8.5 inches ID, 51 inches tall, and a minimum wall of 0.260 inches. So that's what a compressed gas cylinder looks like. A little different than the acetylene, but notice that it's very high pressure, 2000 psi. So if that bronze valve gets knocked off, this thing becomes a missile and it'll punch right through a concrete wall. There's a Mythbusters episode where they knock the lid off one of these and shoot it through a cinder block wall. Acetylene is a colorless, flammable gas composed of carbon and hydrogen, manufactured by the reaction of water and calcium carbide. It is slightly lighter than air. Acetylene burns in the air with an intensity hot, yellow, and luminous, smoky flame. Employers are responsible for safe use of compressed gas cylinders and liquid containers and their contents. Compressed gas hazards include oxygen displacement, explosion, and toxic effects, as well as the physical hazards of a ruptured cylinder. Employers must evaluate compressed gas hazards and have an emergency response plan that defines procedures and responsibilities to address emergencies. OSHA fact sheet on compressed gas safety. Handling of compressed gases. Cylinders must not be used as work rests or rollers. Cylinders may be filled only with the permission of the owner. Should be filled only by a recognized gas supplier or those with the proper training and facilities to do so. Welding must not be performed on gas cylinders. Cylinders must not be allowed to become part of an electrical circuit because arcing may result. Cylinders containing shielding gases used in conjunction with arc welding must not be grounded. Electrode holders, welding torches, cables, hoses, and tools should not be stored on gas cylinders. This is to avoid arcing or interference with valve operation. Arc damaged cylinders may rupture and result in injury or death. Here's an example of the proper storage of compressed gas cylinders. You can see that they're all in little cages and they're all tied up and everything's separated and everything's standing upright. So this is a good example. You don't just want them laying down, laying sideways, scattered about, or just standing up with no support. These are all standing up with support and can't fall over and knock the valve off and cause the respective cylinders to turn into a missile type object. Another example on the right, picture B, you can see all the compressed gas cylinders are tied off against the wall, neatly supported. And then on the left hand side, you've got how not to store compressed gas cylinders. You do not want to have them just standing up and not tied off. This is not a good way to store these compressed gas cylinders. On the right is the correct way, and on the left is the not correct way, as evidenced by the red circle with the slash through it, universal sign for don't do this. Cylinders must not be hoisted using ordinary slings or chains. A proper cradle or a cradle sling that securely retains the cylinder should be used. Electromagnets should not be used to handle cylinders. Cylinders must always be secured by the user against falling during either use or storage. Acetylene and liquefied gas cylinders, dewars, should always be stored and used in the upright position. Gas cylinders and other containers must be stored in accordance with all state and local regulations and the appropriate standards of OSHA and the National Fire Protection Association. Acetylene cylinder storage. Under no circumstances should acetylene cylinders be positioned or stored in other than an upright position. Storage of the cylinder in a horizontal or reclining position could create a hazardous condition. Acetylene stored in a free state under pressure greater than 15 psi can break down from heat or shock and possibly explode. Under pressure of 29.4 psi, acetylene becomes self-explosive and a slight shock can cause it to explode spontaneously. This is why we do not store acetylene cylinders in the horizontal position, only in the upright position. Anything higher than 15 psi is bad, and under pressure of 29.4 psi, the acetylene becomes self-explosive. That is not a good thing. So, like I said, always store acetylene cylinders in the upright position. Compressed gas manifolds. We're going to take a look at manifold systems. Manifolds are used if you use way more gas than you can get out of a single bottle. If you got 50 welders and you're sick of buying bottles, then sometimes you can set up a manifold system or a bulk system. But we're going to talk about manifolds for a couple of slides. A manifold is the supply of welding gases when a volume of gas is needed at a higher volume than can be provided from a single cylinder. A welding gas manifold must be designed for the specific gas and operating pressure and be leak tight. Oxygen and fuel gas manifolds must meet specific design and safety requirements. Manifold piping systems must contain an appropriate overpressure relief valve. Each fuel gas cylinder branch line should incorporate a backflow check valve and a flash arrestor. Backflow check valves also must be installed in each line in each station outlet where fuel gas and oxygen are provided for welding, cutting, or preheating torches. We're going to talk about gases, and not the compressed portion, but we're going to talk about oxygen, fuel gases, fuel gas fires, and shielding gases for a minute. Oxygen is our friend. Oxygen is what we breathe. Without oxygen, we're in trouble. But compressed oxygen and pure oxygen, air is 78% nitrogen. Most of the air we breathe is nitrogen. And there's a 20% plus or minus component of oxygen in the air that we breathe. So we're not breathing pure oxygen. Pure oxygen will catch stuff on fire in a big way. You put oxygen with just about anything and it's an explosion. So do not permit oil or grease to come in contact with compressed oxygen gases. Explosion may occur. Separate oxygen cylinders from those containing flammable gases by a minimum distance of 20 feet or by a non-combustible partition extending not less than 18 inches above and to the sides of the stored material. Never store oxygen cylinders near flammable solvents, combustible materials, unprotected electrical connections, or ignition or heat sources. Yeah, bad things will happen if you expose it to pure oxygen. Shoe polish like in the military. Certain people don't have to polish their shoes in the military because they're dealing with pure oxygen and their boots will catch on fire. So they are prohibited from using shoe polish on their boots. So oxygen, you need to just be careful with it. It's especially when there's combustibles around because it's just going to be a bad thing. Explosions. Oxygen hazards. Oxygen is slightly heavier than air, vapor-specific gravity 1.10. Pure oxygen can be very reactive. Systems must be properly designed, cleaned, and maintained and operated. Use no oil. Oxygen cleaned stickers should be applied to things. Explosions or fires can be initiated by the sudden pressure increase when a cylinder valve is opened if the system is not cleaned or properly maintained. Mixed with a flammable gas, hydrogen, propane, acetylene. This will become explosive, and in welding operations, this can happen if there is no backflow preventer. Fuel gas fires. In a fire situation, there are special precautions that should be taken for acetylene cylinders. All acetylene cylinders are equipped with one or more safety relief devices filled with a low melting point metal. This fusible metal melts at about the boiling point of water. If a fire occurs on or near the acetylene cylinder, the fuse plug will melt. The escaping acetylene may be ignited and will burn with a roaring sound. Immediately evacuate all people from the area. It is difficult to put out such a fire. The best action is to put water on the cylinder to keep it cool and keep all other acetylene cylinders in the area cool. This isn't for you to do, but this is for the fire people, the fire department, which hopefully by this point you have called. The firefighting personnel may attempt to remove the burning cylinder from close proximity to other acetylene cylinders, also from flammable or hazardous materials or from combustible buildings. It is best to allow the gas to burn rather than to allow the acetylene to escape, mix with air, and possibly explode. So you're better off just having the acetylene escape and burn as opposed to escape and explode. If the fire on a cylinder is a small flame around a hose connection or the valve stem or the fuse plug, try to put it out as quickly as possible. A wet glove, a wet heavy cloth, or mud slapped on the flame will frequently extinguish it. Thoroughly wetting the gloves and clothing will help protect the person approaching the cylinder. Avoid getting in line with the fuse plug, which might melt away at any time. Common shielding gases, argon and helium, they're both inert. Nitrogen, carbon dioxide are reactive. They're odorless, colorless, and can displace oxygen. Gases denser than air collect in tank bottoms, vessels, pits, and other low-lying areas. It is in very still air conditions, the denser gases, argon, can act almost like a liquid and will form dense, low-lying layers which will disperse only slowly. Lighter gases may collect in high-level spaces, which could pose a risk if this is at head level. So just be careful with shielding gases. Every year there's some OSHA notices that come out and tell you that about some horrible accident that happened with shielding gases, where 14 bottles of argon were released into a tank and killed 3 welders or whatever. There's always something like that you hear about. So these are things you need to be cognizant of as a weld inspector, because you might be going into one of these spaces. In this module, we covered compressed gas cylinder safety, handling of compressed gases, acetylene cylinder construction, proper storage of compressed gas cylinders, acetylene cylinder storage, manifolds, oxygen hazards, fuel gas fires, and common shielding gases. These are all things that you're going to come in contact with being a weld inspector. Welding involves compressed gases, either for shielding gas, as an oxidizer with oxygen, or fuel with acetylene, propane, and other compressed gases. So you need to be cognizant of, some of the dangers that are out there with these things. I mean, it's a proven way to be able to transport compressed gases from one place to the other in these cylinders. But there is also the inherent danger, because these things are basically a big bomb waiting to go off, because all that stored energy from the compressed gas. So there's a lot of things that can go wrong. Generally, they don't if you're watching what's going on, or the people that are handling or dealing with the gases know what's going on. But there is an inherent danger with these gases and gas cylinders, either for fire, explosion, a projectile situation if one of these falls over and the valve gets knocked off, or there's situations where somebody will drown in this stuff, asphyxiation with CO2 or nitrogen or any of these gases that aren't, there's no oxygen in them. So helium, argon, these things, you can breathe them. They're not poisonous, but there's just no oxygen. It doesn't support life as we know it. So, there's a way to die there. So you need to be reasonably sure that you have an understanding of, compressed gases and compressed gas safety as a weld inspector. We've got one section where it's questions, and more questions. We've got a whole number of CWI self-study question bank, $40. Come on in, take it, take a look, see. If you just need questions, if you sat through another course and you just want to keep hitting the material, check out our question bank, $40. Our CWI CWE online Part A video course, $149. It's self-study CWI exam. Everything's an online video course.